So we are reviewing for the first exam and I have uploaded the questions in Leia. So I hope you printed or you have you have a copy available to you. So let's start. First problem. Let f of x be equal to x plus 2 times x plus 1 quantity squared. Okay. So first is to derive an explicit formula without the summation symbol for the right Riemann sum of the function f of x on the interval -1, 2 using n intervals of equal length. Okay? And then the second problem, a follow-up problem, is to evaluate this definite integral here by finding the limit of Rn as n approaches infinity. So start. So first, we have our A, that's the left endpoint, which is -1. Our B, this is +2. So they come from this guy here, okay? And therefore, if we want the subdivision of the intervals into n subintervals of equal length, then we will have delta x. This is equal to b minus a over n. So this is 2 minus -1 over n, and this is just 3 over n. Okay? Now, our f of x here, it's equal to x plus 2 times x plus 1 quantity squared. Okay? And then what do we do? What do we need? We need our x sub I star. Okay? We need the x sub I star. So x sub I star, this is the right endpoint. It says we want to find R sub n. Okay, and we use this notation to mean that we want the right endpoint. Okay, so anyway, x sub I, this is equal to, or x sub I star, this is equal to the x sub I, but x sub I, this is just a plus I delta x. So our a, it's equal to -1, and we have delta x, that's 3 over n, and then we have the I. And therefore, we are now ready to evaluate the R sub n, or we are now ready to calculate R sub n. This is just the sum from I equals 1 up to n. So this is f of x sub I star delta x. And this is equal to the sum I from 1 up to n f of x sub I star. So let's do this in full details. We have x sub I star plus 2 times x sub I star plus 1 quantity squared. Okay. And then we have our delta x here. And then we substitute. So we have sum I from 1 up to n. X sub I star, it's this guy here. So we will have quantity -1 plus 3 over ni. So that's for this x sub I star here. And then plus 2 times, so -1 plus 3 over ni. And then there's a plus 1 there, quantity squared. And then close parenthesis, and then delta x, it's 3 over n. Okay? 3 over n. So from here, let's just simplify things. we have sum I from 1 up to n. Here we'll just copy -1 plus 3 over ni plus in here, this guy will cancel this. Okay, so we'll just have 2 times 3 over ni quantity squared, and then you have your 3 over n here. Okay, and then we simplify further. Sum I from 1 up to n of -1 plus 3 over ni plus. So in here, we have 3 over ni squared. Okay, that becomes, so we have 2 times 9. So 3 over ni squared, that becomes 9 over n squared I squared. And then, again, everything multiplied to 3 over n. So if we simplify this further, we have sum I from 1 up to n of, we have -1 plus 3 over ni plus 18 over n squared I squared. And then we still have this 3 over n. Okay? So from here, let us use the formulas that we have in here. Okay? In order to write the explicit formula for this. Okay? So let's copy this guy here and then move to the next page so we can have plenty of spaces. So we have somewhere here, we have this, okay? And this will be what? This 3 over n, okay? You look at this, this 3 over n, this is free of I. So we can just bring it out. So we can bring it out as this. And then we have this sum I from 1 up to n -1, of -1 I mean, plus the sum of I from 1 up to n. We have this 3 over n here. We can still bring it out. Okay, at least on this part here. Okay, so we will have, so we have the plus here and then the 3 over n and then we have the I here. And then plus, same is true with this part here. We'll just have 18 over n squared, and then sum of I squared, I from 1 up to n. And then from here, we can directly substitute this hints or this formula for us. It's just, so we have 3 over n times the sum of -1, I from 1 up to n, that's just -n. And then plus, we have 3 over n. The sum of I, okay, I from 1 up to n, we can use this guy here. So we will have n times n plus 1 over 2. Then plus 18 over n squared. We can now use this formula here to evaluate this. So we will have n times n plus 1 times 2n plus 1 divided by 6. Okay? And then if we simplify everything here, so first we can cancel this and this. Okay? And then we can cancel one of this with this. Okay? And then we'll just distribute this 3 over n here. So if we distribute this, we'll just have -3. Okay? We'll have -3. plus 9 over 2 n plus 1 over n. Okay? And then, what else? This guy, we can cancel with this and we'll be left with 3 for this guy. So we'll just have there plus 3 times 3, that's 9. Okay? 9 times n plus 1 times 2n plus 1 over n squared. Over n squared because we have n in here and then we have n in here. So take note that in here only one of the n's was cancelled. So we still have n squared in here. So this is Rn. Okay? This is Rn. Okay? So that's for number 1. Okay? For
Sir?
number 2. Yep.
Wait, that was only number 1?
Yeah, that was only
Okay.
number 1. All right.
Yeah, perfect. Thank you.
Welcome. For number 2, we want to find or we want to evaluate the definite integral. So integral of f of x dx from -1 to 2 by finding the limit of Rn as n approaches infinity. So we evaluate this integral. Okay. And this is just equal to the limit of Rn as n approaches infinity. So this is just limit evaluation. So limit of Rn as n approaches infinity. And we put Rn, it's -3 plus 9 over 2 times n plus 1 over n. Okay? Plus 9 times n plus 1. N plus 1. And let me adjust this, please. So we have here n plus 1 times 2n plus 1 over n squared. Okay? And if we evaluate the limit, we'll just get -3 plus 9 over 2 plus 18. Okay? So I am expecting that you still remember these finding limits. Okay? So that's a skill that you should have learned from your Cal 1. So I will skip the details for that. Okay? So simplifying this, we'll just have what? So 18 minus 3, that's 15. Okay? So you'll get 15 plus 9 over 2, or simply you have 30 over 2 plus 9 over 2. So this is just equal to 39 over 2. So this is the definite integral from -1 up to 2. Okay? Now, if you have this type of problem in your exam and you are asked to find the definite integral by evaluating a Riemann sum, okay, or by finding the limit of the Riemann sum, you should do that. If you do it in another way, then you will not get any point. Because in this particular problem, I want to know whether you know this limit definition of definite integral. Okay? Questions? Next, sketch the graph of this function g of x. Use part A of this item to evaluate this guy here. Okay, this time in terms of area. So we need the graph because we want to find we will be using the area of the region. Okay. So first, we need our axis here. Okay, so we have this and that. And then we need the interval from -2 to +1. So say this is -1, -2. This is +1. Okay. First, let us graph this quarter circle here. So observe this is a part of a circle. The graph of this, okay, is a part of the circle. If you can't see that immediately, you can do something like this. You have y equals square root of 1 minus x squared. Okay, so if you square both sides, you will have y squared equals 1 plus x, or 1 minus x squared, 1 minus x squared, or you can write it as x squared plus y squared equals 1. So this is a circle of radius 1. Okay, this is a circle of radius 1. But from the original equation, from this equation, okay, you only take positive values of y. Okay, so you'll just get the semicircle, okay, semicircle of radius 1. So you will have something like this for this equation. Okay, so for that equation, you will have something like this. But in here, we only need 0 to 1. Okay, so you'll just get this part here. Okay, so for that, the graph will be this part here. Okay, so that's for the this part. For this part here, for this part, it will be easier. It's just a line, so you can just get 2 points on the line, and then you connect the 2 points. You may choose this x equals -2, and then the x equals 0. So notice when x equals 0, if you use this line here, you'll just get what? G of x equals 1. Okay, so g of x equals 1. There's a hole there, but it doesn't matter to us anyway. We will have that. Okay, and then and what? When x equals -2, so when x equals -2, so in here we are using y equals to x plus 1. If x equals 0, then y equals 1. If x equals -2, then y equals, so 2 times -2 plus 1, this is equal to -3. So let's add here -1, -2, and -3, which means the other point will be somewhere here. Okay. And if we connect the 2 points here from this up to this, we'll get this guy here. So we'll get this line. Okay. So what is this guy here? What's the region being considered? So it's between your function and the x-axis. Okay, it's between the function and the x-axis. So the region will be this part here. Okay, so you have this triangle in here. You also have this triangle in here. And then you have this semicircle in here. Okay, so let us label this. this is your, say, region 1. This guy here, let us label this as region 2. This guy here, let us label that as region 3. Okay? Okay? Now, we need this triangle. We need this triangle here. Okay? So this, and this. So we need this base length to find the area of the triangle. Okay? And therefore, we need this point here. Okay? This particular point. So we need the x value when y equals 0, coming from this. Okay? Coming from this. So if y equals 0, then we'll have 2x plus 1 equals 0, or we will get x equals negative 1/2. Okay? So this means that this point here, this is at x equals negative 1/2. Okay? Therefore, what? This guy here, the length of the base in here, it's 1 unit plus 1/2 unit, because this is at x equals 1/2 or negative 1/2. This guy here is x equals negative 1/2, and this is negative 1. So this length here is just 1/2. And then here you have negative 2 until negative 1. That's 1 unit. So the base for this triangle, it's 3 halves. For the height of this triangle, we said earlier, this is just negative 3. So the height of this triangle, it's 3. Okay? Now, for this guy, for the smaller triangle in here, the length of that will be 1/2, because again, from this point up to this point, it's 1/2 units. This guy here, okay, this guy in here, it's x equals negative 1/2. And then the height of this triangle, this smaller triangle here, the height from this point up to this point, it's just 1 unit. Okay? So what? Therefore, integral from negative 2 up to 1 of g of x dx, this is equal to negative area of the region 1. It's negative because, as you can see, this is below the x-axis. Okay? This is below the x-axis. So you need the negative of the area. And then plus the area of region 2 plus the area of region 3. And these two guys, they are plus because they are both above the x-axis. Therefore, we will now have negative. For the area of a triangle, it's 1/2 base times height. So we have 1/2 times the base, it's 3 halves, times the height, it's 3. And then plus, for the region 2, it's the same, 1/2 base times half height. So we have 1/2. The base is 1/2. The height is 1. And then for the circle there, it's just a quarter circle. So we just need pi r squared over 4. Because area of the circle, full circle, it's pi r squared. So quarter circle, we divide it by 4. So we'll just have pi times 1 squared over 4. Okay? And therefore, we simplify this. This will, we will have 9. We have negative 9 over 4 plus 1 over 4 plus pi over 4. So if we simplify this further, negative 9 over 4 plus 1 over 4, that's negative 8 over 4. So we'll have negative 2 plus pi over 4. And this is the final answer. Okay. Let's have our next problem. Find the antiderivative of capital F of x of the function small f of x equals tangent x over cotangent x over cosine. Sorry, f of x equals tangent x plus cotangent squared x all over cosine, satisfying the initial condition capital F of pi over 4 equals 1. So this problem, I think I have given this as a homework or as a seat work. So yeah, let's just show the solution again. Okay. So in here, at this point, we already know that the antiderivative and the indefinite integral are the same. Okay? The antiderivative and the indefinite integral are the same. So we can use now our techniques of integration. Okay? In order to find this capital F of x. So for the solution that I'm going to present here, we'll use indefinite integrals. So in here, we have capital F of x. This is just the integral of small f of x dx. So this is just the integral of tangent x plus cotangent squared x over cosine x, then dx. Then we'll just simplify this tangent plus cotangent squared x over cosine x. We'll see we'll just have tangent x over cosine x plus for the cotangent squared x, let's write it as cosine squared x over sine squared x. That's for your cotangent squared x. And then we still have that 1 over cosine x. So we have this 1 over cosine x here. And then we have the dx. So for this, we have, or we can cancel one of the cosines in here and the cosine in here. So if we simplify this further, tangent x over cosine x, you can rewrite it as tangent x secant of x. Okay? And then we have cosine x over sine squared x. This guy here, we can rewrite it now as cosine x over sine x times 1 over sine x. And rewriting it this way, we can easily see that this guy here, it's equal to cotangent x cosecant x. and then we close this, and then we have the dx here. And now these two guys, they are easily integrable. For the first one, that's just secant x. For the second one, that's just minus cosecant x. And then we have the plus c. So this is the antiderivative, capital F of x. At least this is the general antiderivative, capital F of x of this small f of x in here. Now, it is said that f of pi over 4, this is equal to 1. But using now the general antiderivative, we'll just have secant of pi over 4 minus cosecant of pi over 4, and then this is plus c. But secant pi over 4, that's just square root of 2 minus, same with cosecant pi over 4, that's just square root of 2. And we have the plus c here. So this is just equal to c. Therefore, the desired function, okay, the desired antiderivative is, well, you have capital F of x equals secant x minus cosecant x plus c, which was 1, or which is 1. So this is our final answer. Okay. Questions?
Sir?
Yeah.
C is equal to 1? Like what?
Yes.
Okay. Perfect. Thank you,
C
sir.
equals 1. So we calculated it here. And that's everything equal to 1 here. Next problem. Find the maximum value of this m of x over the interval -1, 3. So in order to determine the value, the maximum value, we will use our knowledge from, or the concept from calculus 1. We will use derivative test, particularly the first derivative test. Okay? So we need to find the critical point. Okay? And to find the critical point, we need to find the derivative of our function. So we need m prime of x. So this is just the dx, so the derivative with respect to x of the integral from -1 up to x squared minus 3. Then you have here t minus 1 dt. So we use first fundamental theorem of calculus here. We get the derivative. What we're going to do is to replace the t here by this guy here, since it's already the upper limit of integration. And here the lower limit is just constant. So we can directly replace the t by this, and then we apply chain rule. So this is x cubed minus 3, x squared. Why am I saying x cubed? So x squared minus 3 minus 1, okay? By chain rule, multiply this to 2x. Okay? So if we simplify this and we factor, we will have 2x times x squared minus 4. Or this guy here, it's just 2x times x minus 2 x plus 2. Okay? So critical numbers, crit numbers, we have m prime of x equals 0 when we have what? So you have 2x times x minus 2 times x plus 2. Okay? This is equal to 0. Or we'll have x equals 0, x minus 2 equals 0, x plus 2 equals 0. Or we have x equals 0, x equals 2, x equals negative 2. So we have 3 candidates for the maximum value. So all we need to do is to evaluate this at each x. Okay? So for that, okay, we'll have m of 0. This is now integral from negative 1 up to negative 3 of t minus 1 dt. So if we integrate this, we'll just have t squared over 2 minus t evaluated from negative 1 up to negative 3. Okay? So this is equal to negative 3 squared over 2 minus negative 3 minus negative 1 squared over 2 minus negative 1. So simplifying, we'll just have 9 halves plus 3 minus 1 half plus 1. So if we simplify this further, we'll just have 9 halves plus 3 plus or minus 3 halves. Okay? So 9 halves minus 3 halves, that's 6 halves. So we will have 3 plus 3, which is equal to 6. So this is for your m of 0. That's for m of 0. Let's have m of 2. M of 2, you will see this will be the same as m of negative 2. Okay? Why? Because if you look at this, you will have the integral from negative 1 up to plus and minus 2 here, but you are squaring it. Okay? And then you have minus 3. So they will be the same. But plus or minus 2, if you square that, that's just 4. So 4 minus 3, that's equal to 1. So the integral will be, or the limits of integration will be from negative 1 up to positive 1. Then you have your t minus 1 dt. So if we evaluate, same as before, this is t squared over 2 minus t. This time we evaluate from negative 1 up to positive 1. So this is equal to, you have 1 half minus 1, okay, minus negative 1 squared over 2 minus negative 1. And if we simplify this, we'll just have negative 1/2, and then minus, you have 1/2 plus 1. 1/2 plus 1. So we'll just get negative 1. So m of 0, we calculated this to be positive 6. So this is 6 here. M of negative 2, which is also equal to m of positive 2, we got this as negative 1. Okay. What else? Take note, the maximum value, it could be at the endpoints. The maximum value could be at the endpoints. Okay? So we are not yet done. We still need to find the value of m at negative 1 and at positive 3. Okay? So we have evaluated m at the critical numbers. We still need to do m of negative 1 as well as m of positive 3. M of negative 1, this is just the integral from negative 1 up to negative 1 squared minus 3 t minus 1 dt. So this is just the integral from negative 1 up to negative 2 of t minus 1 dt. So this will be t squared over 2 minus t. We evaluate this from negative 1 up to negative 2. We'll get negative 2 squared over 2 minus negative 2 minus, here we have again 1/2 or negative 1/2, negative 1 squared over 2. So negative 1 squared over 2 minus negative 1. So all throughout, anyway, this is just 3/2. So we'll just use it again later. So this is what? Negative 2 squared over 2, that's equal to 2. So you will have here 2 plus 2 minus 3/2. So 4 minus 3/2, you have negative 5, you have positive 5/2. Okay? Okay? So correction. Oh yeah, you are right. I got here negative 1 for m of 2 and m of negative 2. It should be negative 2. Thank you. Thank you for that. So it's negative 1/2 minus 3/2. So that's negative 2. And then for m of 3, we have the integral from negative 1, 3 squared minus 3, t minus 1 dt. So here you got the integral from negative 1, 3 squared, it's 9, 9 minus 3, that's 6. And you have t minus 1 dt. Same as before, we have t squared over 2 minus t, evaluated from negative 1 up to 6. And then at 6, we got 6 squared over 2 minus 6. And then at negative 1, again, that's just 3/2. So let's write 3/2. So 6 squared, that's 36. 36 over 2, that's 18. And then 18 minus 6, That's 12. So 12 minus 3 halves. This is 21 over 2. Okay? Okay. Let's write this conclusion here. Okay, let's move it below the calculations that we did in here. So let's have, so m of 0, it was, again, it was 6. M of negative 2, the same as m of positive 2, this is negative 2. M of negative 1, we got 5 halves. And then m of 3, this is 21 over 2. And 21 over 2 is the highest. Therefore, the maximum value is, therefore, the maximum value is 21 over 2. Okay? So take note, we are only interested at the maximum value. If I ask you where does the maximum value occur, then you have to write x equals 3. Okay? That's where this maximum value occurred. Questions? Okay, so why did we choose -1 and 3 again? Because it's on the endpoint. Okay? Because it's the endpoint of the intervals. Take note that when you are calculating maximum and minimum values of a given function using first derivative test, okay? When you apply your first derivative test, the critical numbers will just be inside, strictly inside, okay? Strictly inside the interval. But the endpoints, they are not seen, okay? They are not considered in that first derivative test. So you have to check also the values at the endpoints. Okay? Yes, you can think of it as critical points. -1, -3. Some students think of it or think of them as critical points also, but technically speaking, they are not critical points. Okay? Critical points, these are the solutions to the derivative equals 0. Okay? You have a function, you get the derivative that, you solve the derivative equals 0. Those values are the critical points. The endpoints, if they don't appear in your derivatives as a solution, they are not critical points. They're just merely the endpoints of the interval. Okay? Those are good questions, by the way. All right. So in the last two examples, we considered fundamental theorem of calculus. Okay. So anyway, let's move to our next problem. So we want to evaluate integral of cosine of ln of x dx. Cosine of ln of x dx. So for this, you cannot, if you want to use your substitution rule, you won't be able to do this. It is not helpful. Okay. So we will do this using integration by parts. Okay. So we let u be cosine of ln of x. dv, this is just dx. Now, du, this is negative sine of ln of x by chain rule multiplied to 1 over x dx. V, this is equal to x. So by IBP, integration by parts, you have uv. So x cosine of ln of x minus the integral of negative sine ln of x over x times x dx. Follow? Okay. So if we simplify this, we'll just get x cosine of ln of x plus integral of sine of ln of x dx. And then we do another integration by parts. Let me write now as u1. This is sine ln of x. du1, this is cosine ln of x by chain rule, again multiplied to 1 over x. And then we have the dx. dv1, this is dx. Therefore, v1, this is just x. Therefore, we just copy x cosine of ln of x plus, and then we integrate sine ln of x dx. We use the integration by parts here again. We have x sine ln of x minus the integral of v1 du1. So you will have here integral of cosine ln of x over x times x dx. So again, if we simplify this, we'll just have x cosine of ln of x plus x sine ln of x minus integral of cosine of ln of x dx. And now we are back to our original integral here. But here the coefficient, it's -1. So here, we can bring it to the other side of the equation. So here, you will have integral of cosine of ln of x dx plus integral of cosine of ln of x dx. The first cosine ln of x dx came from this because it is on the left-hand side already. The other integral of cosine of ln of x dx came from this. From minus on the right-hand side, bring it to the left-hand side, it becomes plus. On the right-hand side, we just have x cosine ln of x plus x sine ln of x. But this guy here, if you add, so let me just write it here. If you add this, this is just 2 integral of cosine of ln of x dx. So we divide everything by 2. We will end up with the integral of cosine of ln of x dx. This is equal to x cosine ln of x plus x sine ln of x all over 2, and then Let's just add the arbitrary constant c. And this is the final answer. Okay. Next. Integral of square root of 4x squared minus 9 over x squared dx. Now, observe, you have something in squared variable, okay? Variable squared minus 9, that's just a constant, okay? So you have of the form, okay? You have the form square root of u squared minus a squared. So trig substitution. For this form, we use secant substitution. So we have 2x equals 3 secant x. So if we look at this form here, u, that's just 2x, a, that's just 3. So u equals secant or a secant. U equals a secant of x. Sorry, why am I using x? This is bad notation. I'll use theta. So this is bad notation, very bad. So theta in here. So theta in here. And then you see, if we square it, so 2x quantity squared, that's your 4x squared. You'll get 9 secant squared theta. So square root of 4x squared minus 9, this is equal to square root of 9 secant squared theta minus 9. Let's just completely calculate this. We have square root of 9 times secant squared theta minus 1. So this is just 3 square root of tangent squared theta, or simply we have 3 tangent theta. From here, we have 4x squared equals 9 secant squared theta. Okay? And this means that, so this guy here means that x squared, this is 9 over 4 secant squared theta. From here, we have 2 dx. This is equal to 3 derivative of secant theta. That's secant theta tangent theta d theta. So we are now ready to substitute everything here. We have here integral. This guy, it's this guy, which is this guy. So we have 3 tangent theta. On the denominator, x squared, it's this guy here. So we have 9 over 4 secant squared theta. And then the dx, it's this guy here. So we will have 3 over 2 secant theta tangent theta d theta. Okay? So if we simplify everything here, we'll end up with 2 tangent squared theta divided by secant theta d theta. So this guy here will cancel one of the secant theta. That's why there's one secant theta on the denominator. Of course, 3 times 3 here, that's 9, so it will cancel the 9 here. This guy here will go to the numerator because it's a denominator of the denominator. So you'll have 4 over 2, and that's just 2. Okay? And then from here, what we can do is to transform tangent squared theta. Okay? We'll have, let me bring out the 2 here. So we'll have 2 integral. Tangent squared theta, that's secant squared theta minus 1. Then here you have secant theta. And of course, you have the d theta. And if we simplify this is just the integral. 2 times the integral of secant theta minus 1 over secant theta. That's just cosine theta. D theta here. So if we integrate this, integral of secant theta, this is just ln, absolute value of secant theta plus tangent theta, minus integral of cosine theta, that's sine theta. Then we have the plus c. Okay? But what do we have in here? You got secant theta. So from this here, we write secant theta. Secant theta, it will be 2x over 3, or we have cosine theta equals 3 over 2x. So if we use triangles, okay, this is your theta. Cosine theta equals 3 over 2x. So katowa. Ka, cosine theta, it's adjacent over the hypotenuse. Adjacent here, hypotenuse, it's here. And if you calculate the opposite, this is just square root of 4x squared minus 9. Take note that you can easily get tangent theta from this. You need the tangent theta here, but you can get it directly from here. We need the sine theta, but we don't have any representation of sine theta yet. That's why we will need this triangle. Okay? So finally, we will have 2 times ln. Absolute value. Secant theta, it's 2x over 3 plus tangent theta. So if you use this guy here, Tangent theta, it's just square root of 4x squared minus 9 over 3. And that's consistent with this triangle here. TOA. Tangent theta, it's opposite over the adjacent. So it should be consistent there. And then minus sine theta, it's opposite. So square root of 4x squared over 9 all over the hypotenuse, which is 2x. Then we close this, and then we have the plus c. So this is the final answer for this. Okay? Okay. So there's a question, how did we get tangent theta from ln absolute value of secant theta tangent theta? What do you mean? You mean how this guy here appeared? It's a formula. It's a formula for the integral of secant theta. We derived this before. So we'll just have to use it. So the formula there, although it should be obvious in the solution, but it's the integral of secant theta d theta. This is equal to ln absolute value of secant theta plus tangent theta. Plus c, of course. That's the formula that we were able to derive. Other questions? Let's go to our next problem here. We want to evaluate 5 minus 3x all over 2x squared plus 5x minus 3 dx. So this is a rational expression. I mean this guy here. And therefore, we should use integration by partial fractions. First, we need to factor 2x squared plus 5x minus 3. You need to factor this. Practice your factoring, okay? It should be from Sec 4 or from high school or maybe college algebra. But this guy here, you can factor into 2x minus 1 times x plus 3. That's the factored form of 2x squared plus 5x minus 3. So we have 5 minus 3x over 2x minus 1 times x plus 3. We can rewrite this as a over 2x minus 1 plus b over x plus 3. And then we combine it. Okay, we'll have a times x plus 3 plus b times 2x minus 1 all over 2x minus 1 times x plus 3. So if we compare the numerators, we'll just have 5 minus 3x. This is equal to a times x plus 3 plus b times 2x minus 1. We solve for a and b. We choose x so that one of them disappears. Okay? Or the term containing the A or the B disappears. So if we let x equals -3, this guy here will be 0. So we will only have the B part here. So on the left-hand side, we have 5 minus 3 times -3. On the right-hand side, we just have 5 times 2 times -3 minus 1. So 5 plus 9, this is equal to -7b. So 2 times -3, that's -6. Minus 1, that's -7. The left-hand side, 5 plus 9, this is 14. Which means that b here, it's just 14 over -7, and that's equal to -2. And then we can let x equals 1/2. When x equals 1/2, this guy here will be 0. So it will disappear, and we'll only be left with a. So when x equals 1/2, we have 5 minus 3 times 1/2. This is equal to a times 1/2 plus 3. So we have 5 minus 3 halves. This is equal to 7 halves. A, 1/2 plus 3. So 1/2 plus 6 over 2. So that's 7 halves. 7 halves. 5 minus 3 halves. This is 7 halves also. Which means that A, this is equal to 1. Follow? Which means this integral here now, we can rewrite it as the integral a, that's just 1, over 2x minus 1, plus b, that's minus 2. So I'll write minus 2 over x plus 3. And then you have the dx. And when we integrate this is just ln, absolute value of 2x minus 1 divided by 2 minus 2 ln absolute value of x plus 3 plus the arbitrary constant c. So this is the final answer. Okay. Questions? Next, evaluate integral from -1 up to 2 of the absolute value of x to the 4 minus x dx. Okay. Now, for this, okay, let us look first for let us study x to the 4 minus x. We factor this. This is just x times x cubed minus 1.
Sir?
Yeah.
Will we go back to the previous example?
Okay. Here it is.
No, I mean the one before this, 6A.
It's this guy.
Okay, never mind.
Okay. 6A, is it this guy? Anyway, so we have this. Maybe you are talking about this guy here. We'll do that after this. So we have an example in the PDF that you sent us that you don't have. It's actually this guy. I maybe when I was typing it, I interchanged them. But anyway, so we'll see that later. So for this, we study first x to the 4 minus x. We factor that into x times x cubed minus 1. And we further factor this into x times x minus 1 times x squared plus x plus 1. Yep, question? David.
Sir, why can't we just do 1 over 5x to the power of 5 minus 1
No,
over
you
2?
cannot do that because of the absolute value here.
So what are we allowed to do during absolute value?
This is what we're doing. You have to remember the following. Absolute value of x, if you want to remove this, you have to divide this into two parts. It will be x if x is greater than or equal to 0, and it will be negative x if x is less than 0. So if the thing inside, the expression inside the absolute value is some p of x, you also need to do that. It will just be p of x if p of x, this is greater than or equal to 0. And it should be negative p of x if p of x is less than 0. So that's what we're going to do. That's the reason why we need to do this part, because we have to separate those with the positives and those with the negatives. So this is not as easy as just integrating it. No, the absolute value has an effect there when you do the integration. So this is what you need to recall. Okay? When you have that absolute value thing. So how do we do this? X to the 4 minus x can be factored into this expression. Oh yes, question?
Yes, sir. I didn't understand how do you factor it?
Difference, of course, your x, you factor this x easily. For this guy here, this is difference of 2 cubes. There is a formula that you should remember from your Sec 4. It's difference of 2 cubes. So we just use that. The actual formula is something like this. X cubed plus or minus a cubed. This is x minus a times x squared plus ax plus a squared. This is the formula. So we just used it. Okay? All right. So now we have this factored form. We now have this factored form. Now, x to the 4 minus x equals 0 when If you look at this factored form here, it will be 0 when x equals 0 and also x equals 1. You just calculate this guy here. You equate this to 0. Okay? X equals 0 will be coming from this. X equals 1 will be coming from this. This guy here, it will never be 0 for any x. So you'll just have those two guys. Okay? Now, you have the interval -1 up to 2. So, let's see. Say this is your -1 here. This is the 0. This is 1. And this is the last part. This is your 2. Okay? And then what are your functions? You have your x, you have your x minus 1, and you have that x squared plus x plus 1. If you multiply these three guys here, you'll end up with x to the 4 minus x. We need to get the signs. Take note, for this part here, when x is between -1 and 0, this is negative. And when x is greater than 0, well, this is positive here and positive here. For this part here, when x is between -1 and 0, this is negative. When x is between 0 and 1, this is still negative. And when x is greater than 1, this is positive. And then, like I said, this is always positive. This guy here, it's always positive. So, if you multiply these three, you will get some number. Okay? If you multiply those three guys there, you will get this x to the 4 minus x. The question is, what is the sign of x to the 4 minus x? All you need to do is to multiply the signs. For this, minus times minus times plus, you'll get this plus. For this, plus times minus times plus, you'll get minus here. And finally, for this, plus times plus times plus, you'll get plus here. So what does this mean? This means the absolute value of x to the 4 minus x, this is what? You can just copy x to the 4 minus x if that expression is positive. That expression is positive for this and this. It means in this interval and in this interval here. So you'll just copy x to the 4 minus x if your interval, or if your x belongs to the interval -1 to 0 or 1 up to 2. And then you'll have to put the negative. Okay, so you will have negative of x to the 4 minus x if p of x is negative. It's this guy here, but the interval is 0, 1. So you put the negative if your x belongs to the interval 0, 1. Therefore, the integral from -1 up to 2 of the absolute value of x to the 4 minus x dx, this will be equal to the integral. Let's start with -1 up to 0. On this interval, we use this. So we can remove the absolute value there, x to the 4 minus x dx. Plus, on the next interval, 0 to 1, on this interval, okay, we need to put the negative. So you will have negative x to the 4 plus x. And then finally, for the interval 1 up to 2, so you have this interval here and you have positive x to the 4 minus x. So we'll just copy x to the 4 minus x, and then you have the dx here. Okay? And now you can easily evaluate this. There's no absolute values on the right hand side anymore. So if we do this, we evaluate this, this is just x to the 5 over 5 minus x squared over 2, evaluated from -1 to 0. And then plus minus x to the 5 over 5 plus x squared over 2, evaluated from 0 to 1, plus x to the 5 over 5 minus x squared over 2, evaluated from 1 up to 2. So calculating, we'll just have here 0 minus the quantity. -1 over 5 minus 1/2 plus, here we have -1 over 5 plus 1/2 minus 0, and then plus 2 raised to 5 over 5 minus 2 squared over 2 minus quantity 1 over 5 minus 1/2. And then you simplify this. Okay? So if we simplify this, let me do the simplification somewhere here. We have 1 over 5 plus 1/2 minus 1 over 5 plus 1/2 plus 32 over 5 minus 4 over 2, so that's just minus 2, minus 1 over 5 plus 1/2. So what can we cancel in here? I will be able to cancel this guy and this guy. Okay? And then I have here plus 1/2, plus 1/2, plus 1/2, that's 3 halves. And then I have here 32 over 5 minus 1 over 5, that's plus 31 over 5, and then we have the minus 2 here. And then we can simplify this even further. 3 halves minus 2, that's -1/2. So we have 31 over 5 minus 1/2. So over 10, 31 times 2, that's 62. 1 times 5. So here we have minus 5. So the final answer will be 57 over 10. This is the final answer. Phew. Okay. So again, this is absolute value here. Okay. This is absolute value here. You just don't evaluate it. I think we discussed something like this when we were solving total distance traveled. So you need to get the integral of the absolute value of v of t. So this is not new to us. We did that. We did the same solution as in that one. Okay. Next problem here. We have the integral from 0 to 1 of dx over 1 plus square root of x quantity squared. So for this, we just use substitution rule. Okay? So we can let u be equal to 1 plus square root of x. Du, this is 1 over 2 square root of x dx. From here, we have square root of x. This is equal to u minus 1, which means for this, we will have dx. This is equal to 2 square root of x du. But square root of x, it's u minus 1. So you have 2 times u minus 1 du. Therefore, let us get the new limits of integration, by the way. If x equals 0, then u equals 1 plus square root of 0. This is just 1. If x equals 1, then u equals 1 plus square root of 1. This is just 2. Which means we will have integral from 1 up to 2. Dx, it's 2 times u minus 1 du. 1 plus square root of x, that's u. So in the denominator, we have u squared. Therefore, if we simplify this, let us bring out 2 outside here. You have 2 times the integral from 1 up to 2. And then u over u squared, that's 1 over u, minus 1 over u squared, that's 1 over u squared. And then we have the du here. And this guy here, we will have 2 integral of 1 over u. That's ln, absolute value of u, minus integral of 1 over u squared. So we have here integral of u raised to negative 2 du. We'll just get u raised to negative 1 over negative 1 plus c. So in here, we'll just have plus u raised to negative 1. And then we evaluate this from 1 up to 2. So this is equal to 2 times ln of absolute value of 2. So ln of 2 plus u raised to negative 1. I'll put it as 1 over 2. Okay? And then minus quantity ln absolute value of 1, it's just 1. So ln of 1 plus 1. So if we simplify this is just 2 ln of 2 plus 1 half. Ln of 1, it's 0. And then we have the plus 1 there, so we have minus 1 in here. And if we simplify this, we'll just get 2 ln of 2 minus 1. So 1 half minus 1, that's negative 1 half, but we have the 2 outside. So that's why we just have minus 1 in here. So this is the final answer. Okay? Questions? Finally, let's do this. This will be our last example for this review session, and we'll continue our review tomorrow. So we'll answer the second part of the, well, it's the previous second exam, the one I gave several terms ago. But anyway, so here, given that f is continuous on the interval 0, 1, f of 0 equals negative 1, and that the integral from 0 to 1 of f of x plus f prime of x e to the x dx equals 2, find the exact value of f of 1. Okay? So for this, okay, for this, we will divide this into two parts. So we have the integral from 0 to 1, f of x e to the x dx. And then we have the plus integral from 0 to 1 of f prime of x e to the x dx. Okay? And then, let's see. From here, we study this part. Okay? We use integration by parts. Okay? We let u be equal to f of x, and therefore dv, this is e to the x dx. Du, this is f prime of x dx. V, this is e to the x. Okay? So, for that part, we have uv. So, e to the x f of x, that's your uv, minus the integral. Sorry, we have to evaluate this from 0 to 1. And then minus the integral from 0 to 1 of v du. We have e to the x f prime of x dx. That's your v du. But we still have this part here. So we have the plus integral from 0 to 1 of f prime of x e to the x dx. Notice these two guys are just canceling each other. This guy here is the same as this guy here, but one is positive, one is negative. Therefore, this is just what? E to the x f of x from 0 to 1. And then if we evaluate this at 1, we have e to the 1, which is just e, multiplied to f of 1. At 0, we have e to the 0. E to the 0, it's just 1. And then you have f of 0. So this is just e. So I'll put e to the 1 first, but e to the 1, it's just e. So here we have e times f of 1 minus e to the 0, that's just 1. And f of 0, it's given to be negative 1. So f of 0, this is negative 1. So simply this is just e times f of 1 plus 1. But this guy here, it's this guy here. Okay? So e f of 1 plus 1. This is just the integral from 0 to 1 of f of x plus f prime of x e to the x dx. And from the given, this is just positive 2. So we can solve for f of 1. So this means we have e f of 1, this is 2 minus 1, which is equal to 1, which implies that f of 1, this is 1 over e. So this is the final answer. Okay.